Hi class. In this lecture here, we're going to continue talking about graphs of other trigonometric functions by now talking about the cotangent function. And so what you should do, or make sure you have done before you watch this lecture, is make sure you've watched the lecture where I talked about how you graph the tangent function, okay? A lot of the concepts from that lecture are going to be very, very similar here. And, just having watched that lecture, it's helpful before jumping into this one. Okay, so all we're going to do in this lecture today is we're going to talk about how you understand the graph of y is equal to just cotangent of x. So basically what I'm going to do is I'm going to graph one period of this just so you can get an understanding of what the basic graph looks like. And then I'll talk about some of the properties of the cotangent graph, y is equal to cotangent graph, cotangent of x graph. And then what we're going to do is we're going to do 3 examples of talking about how you graph variations of y is equal to cotangent of x. Okay, and it's going to be I'm going to do varying difficulties of these examples of graphing these variations, and as we go through them, consider pausing the lecture after I put a problem up and giving it a shot, and trying a little bit on your own, and then you'll obviously get a chance to practice this some. Okay, so let's jump right into it. So let's talk about let's sketch the graph of, let's look at y is equal to cotangent of x, and let's just graph it on this interval. So 0 is less than x, less than pi, okay? And you're going to notice, just like in the previous lecture when we did the tangent graph, I have these strict inequalities here, okay? But we're gonna set up the graph, okay, using the same idea. We're gonna find some test value. We're gonna pick some values of x and find points to plot. But to be able to do this, you need to recall this quotient identity. So cotangent of x is equal to cosine of x divided by sine of x. Like, that's just how we defined cotangent. So we're going to use the unit circle here and the cosine and sine functions to help us evaluate for cotangent of x. All right. So we're going to pick some test points or test values here. Okay. So even though we have 0 here, all right, it says greater than 0. I'm actually going to just pick 0 and I'm going to plug it in and show you what happens. So I want to go from 0 to pi. Well, look, here's pi over 4. I'm going to pick, these are the test values I'm going to pick, and you'll see why in a little bit. Pi over 4. I'm going to pick pi over 2 and 3 pi over 4 as some of my test points to plug in. And then I'm also going to pick pi, okay? And I'm just, even though I want to graph it less than pi, I want to show you what happens here. All right, so y is equal to cotangent of x, which is the same thing as cosine of x over sine of x. All right, so let's see what cotangent of 0 is. Well, here's 0. What is cosine of 0? Well, that's 1. What is sine of 0? Because I'm plugging it in here, right? If it helps to see this, this is cosine of 0 divided by sine of 0. Well, that's 1 divided by 0. So you're getting a divide by 0 here. All right, obviously, you can't have a divide by 0. So what does that mean? That means cotangent is undefined here. And when we have this 1 divided by 0, what this means here is you're running up against a vertical asymptote. So just like the tangent graph here, this cotangent graph has vertical asymptotes. Now let's try pi over 4. Well, look here. Go to pi over 4. All right, what is cosine of pi over 4? Square root of 2 over 2. What is sine? Square root of 2 over 2. So square root of 2 over 2 divided by square root of 2 over 2, that's just 1. So we have our first actual point we can plot. We have the point, comma, pi over 4, comma 1. Now let's continue. Y is equal to cotangent of pi over 2. Well, look, pi over 2. Cosine is 0, sine is 1, so that's 0 divided by 1, which is just 0. So this is pi over 2, comma 0. Y is equal to, now we're going to plug in 3 pi over 4. This is great. Let's see what happens. Here's 3 pi over 4. Cosine is negative the square root of 2 over 2. We're going to divide this by sine, which is the square root of 2 over 2. So that's just going to be negative 1. So that's 3 pi over 4, comma negative 1. And then check out this. This is awesome. When you plug in pi, it's going to be cosine of pi over sine of pi. Well, look what you get. You get negative 1 divided by 0. Well, again, you get to divide by 0, so it's undefined there, which means we've found, just like we did with the tangent graph, we found the next consecutive vertical asymptote. So now you're going to use, just like, and this is important, just like with the tangent graph, okay, just like with the tangent graph, you're going to use these vertical asymptotes to help you plot the graph. So here's x, here's y, here's 0, x is equal to 0. Then I have pi over 4, pi over 2, 3 pi over 2, and then pi. And look what's happening here. At pi, you have this vertical asymptote, like this. At the y-axis here, x is equal to 0, you also have a vertical asymptote. So pi over 4, here's 1, here's minus 1, pi over 4, 1, pi over 2, 0, and, oh, I wrote 3 pi over 2. Sorry about that, just by habit. A little bit of a typo there. 3 pi over 4, sorry about that again. 3 pi over 4, you have negative 1. And look, you're going to butt up against these asymptotes. So you can see, not the greatest graph, my apologies, but you can see the pattern here. And this is what the graph of the cotangent function is going to look like between 0 and pi. All right? And so this graph is also a periodic function, or this cotangent is also a periodic function. So this graph is just going to continue to repeat itself. All right, you can see here, I have the characteristics of it. All right, so the period, it's going to repeat itself every pi. So just like tangent. The domain is all real numbers except integral integer. That didn't mean integral. Integer. A little bit of a typo there. Integer multiples of pi. Sorry about that typo. And then the range here, because it's butting up against the asymptotes each side here, going shoop, up to positive infinity and down to negative infinity, the range is all real numbers. And look, you can see this. If you look in your calculator, you'll notice that there's no there's no cotangent function here, right? So if you wanted to plot this, right, you could go y is equal to, and remember what it is, okay? It's cosine of x divided by sine of x. And look, you can see that the graph in your calculator is exactly the same graph you see here. All right, so what we're going to talk about now is now we want to begin talking about like how you're going to sketch this graph, okay? And you're going to need to know these characteristics, and you're going to notice it's going to be a lot like the tangent graph, okay? So the characteristics are, you're going to need to know that the vertical asymptotes occur at, again, sorry about these typos, integer multiples of pi. An x-intercept occurs midway between each pair of consecutive asymptotes. Okay, so you'll notice here, midway between, midway between, midway between the asymptotes. You get that x-intercept. That's going to be important to help us graph. All right, it's an odd function with origin symmetry. And then this is the big point here. The points of the graph 1/4 and 3/4 of the way between consecutive asymptotes have y-coordinates of 1 and -1 respectively. Like you see here, 1/4 of the way, 3/4 of the way, 1 -1. So we're going to use that property, just like we did with tangent, to help us sketch the graph. Okay. All right, so here's going to be how we're going to do it. We're going to talk about how you're going to graph y is equal to a times cotangent of bx minus c. Okay, and this is when b is greater than 0. So just like we did with tangent, the first thing you're going to do, or the most important thing you're going to do, is you're going to find 2 consecutive asymptotes. Okay, this time you're going to do it by looking at this. Okay, 0 is less than whatever inside the cotangent function. Bx minus c also has to be less than pi. So we're going to solve this for x. All right, and then you're going to have a pair of consecutive asymptotes. Here, first, where bx minus c is equal to 0, and then where bx minus c is equal to pi. Those are incredibly important. What you're going to do is you have to set those up, and then you're going to notice as I go through this, it's going to go boop, 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 boop. It's going to fall right into place. Then you're going to identify an x-intercept midway between the consecutive asymptotes. Okay. Then you're going to find the points on the graph 1/4 and 3/4 of the way between consecutive asymptotes. These points have y-coordinates. This is where the a comes in, of a and minus a respectively. And then you're going to use these steps 1 through 3 to graph one full period of the function. Okay. Add additional cycles to the left or right as needed. So in all the problems we're going to do today, I'm going to ask you to graph 2 cycles or 2 periods of the graph. And trust me, the more you practice this, the easier it will get. And don't worry if initially you're kind of looking at this and you're like, this is a little tricky. Trust me, as you see me do more examples, you'll notice the pattern, and it's going to get easier and easier and easier. I promise. Okay. All right, so you're going to use this basic property here that's just described there. Find the 2 asymptotes, midpoint, 1/4, 3/4, and then you're going to get these 3 points, and you're going to butt up against the asymptotes. All right, so let's graph 2 periods of this function, or this equation here. Y is equal to 2 times cotangent of 1/2 x. All right, so I want to graph 2 periods of this. All right, just like with the tangent function, the key is to find 2 consecutive asymptotes. That's the key. That's key. Once you do that, you're going to notice, boom, boom, it's really going to fall into place. So you take what's inside here. Okay, this is my A. This is my B. There is no C, so there is no phase shift here. Okay? So this B is going to mess with the period. So just so we're clear, right, the period here, you take the period and divide it by B. So this is pi divided by 1/2. So you're going to notice here that instead of the period being the initial pi here, because we have this value b in front of x, is now 2 pi. All right, so all you do is you take this. 0 is less than, you take what's inside here, 1/2 x is less than pi. So to get x by itself, you're just going to multiply everything by 2. Well, 0 times 2, that's still 0. 2 times 1/2, that's just x. And then 2 times pi is just 2 pi. Okay, so what this means is you've now found the 2 consecutive asymptotes, okay? So we have 2 consecutive asymptotes. At this. So x is equal to 0, so that's the y-axis. and now at x is equal to 2 pi. All right, and you're going to use this, right? You're going to use this, then the midpoint between them is the x-intercept, and then you're going to find points 1/4 and 3/4 of the way through. All right, let's do it. So we're going to graph 2 periods of y is equal to 2 cotangent of 1/2 x. All right, so our first asymptote occurred at x is equal to 0. Okay, so the y-axis. Then we have one out at 2 pi. All right, well, because the period is 2 pi, another 2 pi away from here. So it's going to repeat itself. So 2 pi away from 2 pi gets me 4 pi. There's going to be another vertical asymptote. All right, well, what is the midpoint between 0 and pi? Or 0 and 2 pi? Well, that's just pi. Then the midpoint between 2 pi and 4 pi is 3 pi. And look, boom, boom. Those are the x-intercepts. So between 0 and pi is pi over 2. Between pi and 2 pi is 3 pi over 2. And you're going to have to go up to a and down to negative a. So then look, at this first quarter value, you're at a, then you're at 0, and then you're at negative a. So this graph is just going to look like this. All right, so what's the value between 2 pi and 3 pi? It's 2.5 pi, or 5 pi over 2. And between 3 and 4 pi is 3.5 over 2, or 7 pi over 2. And you get the same thing. 2, 0, negative 2. And it looks, sorry, that graph is a little sloppy, but you get the idea. You know, so again, it's just the asymptotes. Once you find the asymptotes, then it's just like boom, boom, boom. It kind of begins to fall into place here. All right, let's try another one, okay? And this one I'm gonna we'll end on a phase shift. So we'll do another, just another general one where we're gonna mess with the period here, okay? All right, I'm going to go to the next one here. So let's graph 2 periods of this graph here. So y is equal to 3 times cotangent of pi over 4 times x. All right, so this is my a. And this is my b. All right, so you could, if it helps to do this, the period here, you're going to take pi and divide it by pi over 4. Keep, change, flip, you end up getting pi times 4 over pi, which is just 4. And this is important. I know I've covered this in previous lectures, but whenever there's like something with a pi in here, okay, your period is going to, the pi's are going to cancel out, and your period is just going to be, generally it'll be an integer or some rational number. And it'll work out really, and it's going to work out really, really nicely. So the key again is find 2 consecutive asymptotes. So with the cotangent, you just set up 0 is less than what's ever inside here, pi over 4x, which is less than pi. All right, so to get x by itself, you're going to multiply each side by 4 divided by pi. Well, 4 divided by pi times 0 is just 0. These cancel out here. And then look what cancels out here, the pi's. So it's just less than 4. So this makes it so easy here. This makes it so nice. Okay, so that means you have a vertical asymptote at x is equal to 0. So at the y-axis, and then you have another one at x is equal to 4. You're gonna notice this problem is really great. It's gonna be just so easy to graph this when you don't have to worry about like the pi's here. Okay, anything with the pi along the x-axis here. Okay, so let's sketch again, going 2 periods of y is equal to 3 cotangent of pi over 4x. Okay, so we have a vertical asymptote at x is equal to 0. Here's 1, here's 2, here's 3, here's 4. There's the next vertical asymptote. And then remember, the period is every 4, so there's going to be another vertical asymptote at x is equal to 8. And then look, what falls in the middle here? The first quarter is 1. Three-fourths of a quarter here between it, which is the number 3, is down to -3. Between 4 and 8, the middle is 6, so that means the number 5 is 1/4 of the way between, and the number 7 is 3/4 of the way between. And it so beautifully falls into place when you set this up like this. Okay, it becomes so easy to graph when you follow this method. You know, like I hope as you're watching this, you're seeing like, once you find the asymptotes, it's like boom, boom, boom. It just very quickly falls into place. All right, let's do let's end on a problem, a phase shift problem. Okay. So let's sketch 2 periods of, let's look at y is equal to cotangent of x plus pi over 2. Okay. So again, what's the key? What's the key? The key here is to find those 2 asymptotes. So you're going to take whatever inside here and put it between 0 and pi. All right, so just to solve this, right? Just to solve this, you're just going to get x by itself, you're just going to subtract pi over 2. So 0 minus pi over 2 is minus pi over 2. Here they cancel out. And pi minus pi over 2, it's just pi over 2. All right, there's no value, right, in front of x. So the period here is just pi divided by 1. So it's just pi. And you see that, right? Like the distance between negative pi over 2 and pi over 2 is pi. So our first vertical asymptote We have one at x is equal to negative pi over 2. And then we have another one at x is equal to pi over 2. And you're going to notice, this is going to be amazing. You're going to notice that once you set this up with the asymptotes, boom, 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 it's going to fall right into place here. Okay. Let's sketch 2 periods of this y is equal to cotangent of x plus pi over 2. All right, so we need to go to negative pi over 2 is the first one, and then pi over 2 is the next one. Okay, so things are going to repeat themselves every pi, right? So another pi from this. So pi over 2 plus pi is going to give me 3 pi over 2 is the next vertical asymptote. Okay, so watch this. Right in the middle of negative pi over 2 and pi over 2 is 0. Between pi over 2 and 3 pi over 2 is pi. So there's that next one there. Between negative pi over 2 and 0 is negative pi over 4. And then obviously between 0 and pi over 2 is pi over 4. And so look, 1, 0, negative 1, and then butt up against the asymptotes. And then what falls between pi over 2 and pi? That's that 3 pi over 4, and then obviously over here it's 5 pi over 4. 1, 0, negative 1. And we got it. All right, class. Again, you're good. Practice, 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 right? The more you do and the more you watch these videos, and, sometimes it helps to, you've watched the video once, go back and try to solve these problems on your own, and then come back and check and see how you did. And then, as always, if you have any questions, I am here to help.